Find minimum in rotated sorted array. Suppose an array of length and sorted in ascending order is rotated between 1 and n times. For example, the array nums 0, 1, 2, 3, 4, 5, 6, 7 might become this one if rotated 4 times, and this if same one if it's rotated 7 times. Notice that rotating an array, this, so for example, this one time it results in, so the ending becomes the beginning. Given the sorted rotated array nums of unique elements, uh, return the minimum element of this array. So this is what we need to return. Let's keep this noted so that we know exactly what we're going to do, what we need to return. You must write the algorithm in O of n times, of log n time. So now this what we this it must be written in log of n time. So we're going to use a binary for this binary search. So our binary search time complexity of log n space complexity of 1, since we're going to use the same variables, few variables, left, right, and our pointer, mid pointer. So these are the examples. We're given this list, and our output should be our minimum value. This one also 0 is our minimum value here, so we have the output here, and this one has the output here. So let's make our basic variables for binary search. So let's make our left pointer, our right pointer equals to, our left pointer equals to 0, our right pointer is now equals to len of right underscore pointer. So while our our left pointer is less than our right pointer, so this loop will keep going on until our left pointer is less than our right, as long as our left pointer is longer than our right pointer. So meaning our left pointer should be equal to our right pointer eventually, or else. So let's calculate our midpoint. I'll call midpoint equals to right pointer plus left pointer divided by 2. So in this case, this is our left pointer, right pointer, 0, 1, 2, 3, 4, 4 plus 0 is 4 divided by 2 is 0, 1, 2. This is our midpoint over here now. So if our that for midpoint is in this case it's bigger than our right pointer, our right that right pointer value, if our midpoint value in nums is greater than our right pointer. Let's move our left pointer equals to midpoint plus 1. So since this one is bigger than this, that means that this can be our minimum value. So let's move this left pointer to this and then add 1 to it. This is our minimum value, but we're not done yet with this. So else, if it's not, like in this case, else right pointer, as if it's less than, which is going to be in the right pointer is equals to our mid point. So if it's not, for example, in this case, this one is the midpoint over here. This is our index 0, 1, 2, 3, 0, 1, 2, 3, 3 divided by 2 is 1 with the rounded round to the nearest whole low. Rounded down is 0, 1. It's 1. This one over here. So our midpoint over here is less than this. Isn't bigger than this one. So this one will now be equal to this. So this will be our left pointer and this is our right pointer. And so we go on to the loop again. So 0 plus 1 divided by 2. 0 plus 1 divided by 2 is it's actually 1. 1 divided by 2 is 0.5, but with this sign we have to round down to the nearest whole number. So now this is our left pointer, our right point, our midpoint value over here. So, and this is our left pointer again, and so is our right pointer. Our right pointer isn't this. So since this isn't our midpoint value, still isn't greater than this. Now our right pointer is now equals to this. So now our left pointer and our right pointer is 0, 0 divided by 2 is 0. So now they're both equal. So since both of these are equal, it's no longer the case that our left pointer is less than our right pointer. So now let's get out of the loop, return norms dot left pointer. So let's see if there's any mistakes that need to be fixed. Let's give this closer so that we know where it's associated. Right point, left point, right point. Let's find it and see. Hopefully there's no mistakes. If there is, it can be fixed quickly. Variable right pointer where it's not assigned a value. Word. The length of nums. Nums. Should be nums, length of nums. Right pointer is less than if nums dot midpoint is range out of sorry, should be -1. It's the same. Then that's it. It's been able to run properly. Let's submit it and see if it passes all cases. And that's it. It's been successful, passing all cases. And this is another form of binary search with a sorted rotated array.